Excited that you're joining us today to talk about the upcoming new release of ISC DHCP. So our presentation today is going to run about 45 minutes. All attendees are going to be on mute. We will have a time at the end of this webinar for questions and hopefully answers. You can ask questions at any time, and please do so through your WebEx Q&A or chat window to submit questions to us. But again, we'll be holding those until after the presentation, but we'll be addressing them at that time. If we get more questions than we have time, we will ask you to please send any unanswered questions directly to info@isc.org. Those questions are important to us, and we'll follow up with you privately. Note that, as we do with all of our webinars, this event will be recorded, and you will be receiving a recording of the event along with a link to the presentation so that you can refer back to it if you need to, or also we ask that you share it with any other parties that you think may be interested in this topic. So a bit about our presenters today. I'm Eddie Winstead, but we also have with us Sean Routhier, who is our one of our senior software engineers and is the lead developer on ISC DHCP 4.x. We're really fortunate to have Sean with us, both just in general at ISC. He's been involved with the standards process for quite a long time, so we're fortunate to have him, but we're also fortunate to have him on the call today. He's been very busily preparing for the release of 4.3, and so we appreciate him taking time out with us to talk about some of the features that we think you're going to find beneficial in 4.3. Myself, again, I'm Eddie Winstead. I'm a senior engineer here at ISC, and I do a lot of things here. I've done lots of configuration audits, lots of support of for folks that are using our software in mission-critical situations. Done a lot of consulting for us, and I'm also one of the instructors for our trainings that we do on DNS and bind, DHCP, as well as IPv6. And those that have attended prior webinars, I'm sure you know me by now. So our agenda is very simply, we're going to talk about what's going into ISC DHCP 4.3. We'll talk about the major features and ones that we think are going to benefit you the most. We'll talk about some submitted code. We'll have a little bit of time, maybe some discussion on other new features, and then we'll take your questions, as I mentioned earlier. Now, before we get started with all that, we'd like to pause for one moment and say happy birthday to ISC DHCP, which turned 18 years old about 15 days ago. So most of us are connected to at least one device at this moment that has obtained an IP address from an ISC DHCP server. So we're very happy that that the code has been around that long and has been useful for that long and still proves to be useful today. And we're excited to be a part of that. So if we take a look at a little closer, more recent history of ISC DHCP, for release 4.1, we released back in December of 2008. And 4.1 became what is our ESB release, or extended support version, and still remains so. And you'll see listed there that we have some IPv6 support in 4.1 and 4.2 as well. But what we really want to focus on today is that we're terming that 4.3 as the IPv6 feature uplift. So there's been a lot that has happened in the standards process regarding IPv6 and DHCPv6, and so 4.3 is really an effort to get a lot of those developments into place in the code. 4.2 is also mentioned there, and for those of you that are making use of dynamic DNS or DDNS, likely you are using 4.2 as it introduced asynchronous DDNS, which was a big performance improvement. We will be talking about some DDNS changes that are also occurring in 4.3, and so we'll let you know about those as we move forward here. So again, the major part of 4.3 is the IPv6 feature uplift, and these four items here are the ones that we think are going to be most beneficial to you and of most interest to you. So what we're going to do is we're going to walk through some scenarios in which you may make use of these options, and it's really handy to have Sean on with us because he's going to take us through how you would actually do these in the config and show you some command line things as we go on. We'd like to actually start off, we're going to be talking about relay options first, and so we'd actually like to start off with a quick poll and ask, are you using relay options in DHCP v4? And as well, do you plan to make use of relay options in DHCP v6? And while you're doing that, we'll continue on with the presentation. So the first scenario we're looking at here is essentially you have a building somewhere on a campus that right now we're just taking a look at a few clients on the 3rd and 4th floor. We also have a DHCP v6 server in this building. Now the clients are connecting to an IPv6 network, but the network topology through which they reach the DHCP v6 server is a little different. And so when those requests arrive at the DHCP v6 server, there may be some things a little different about what the server is seeing and how the server handles that. And so as I flip to this next slide, I'd like to ask Sean to talk about how things are looking here at the packet level and what the DHCP v6 server is going to be able to do in 4.3.
Thank you, Eddie. So the biggest difference in v6 relays versus v4 relays is that the v6 relay encapsulates the entire packet from the client. In v4, the relay would simply insert whatever options it wanted to into the client, into the single packet, and then pass it along. In v6, it does this encapsulation, so you can see that the bottom line, the client packet starts off the little blue box to the left, then it moves to the relay and gets encapsulated, and then it moves to the next relay and gets encapsulated again. You can have up to 32 relays in line. Again, you could have multiple relays in v4, but typically the protocol didn't really allow for more than one to add things and to understand what was going on. Next slide, please.
Okay.
So in this case, we can see the two little dots in the middle packet there. That's the middle relay adding the remote ID and the relay ID. And then we can see the single additional relay ID from the more rightmost relay. So we can have multiples of these. And the basic problem that we are addressing in 4.3 is while we did decode all these options, we did not make them available to the administrator to do anything with. So in v4, you could use a relay option to make a decision as to what information you'd hand out. In v6, we didn't give you the capability of getting to that information. So we've now added a new option to allow you to specify which of the relays you want and which of the options you want.
Okay, excellent. And so with this next slide, could you walk us through what the remote ID option might look like in that case?
Yep. So this is the remote ID option. It's partially specified by the IETF, the enterprise ID, and they suggest, but it's not a sort of a hard requirement that you use the relay DUID to make the information unique. And then you could add whatever you want. It's up to the manufacturer what they want to put in there. So you could put in, for example, a switch type or a router type, and then you could add whatever specific identifying information you want for that particular device. So in this case, you might imagine a switch for an ISP where the port or circuit number specifies the actual client. And if you knew how this information was laid out, you could write up a class or something like that that would extract the appropriate information to make a decision that this particular circuit number means this particular client ID and hand it the appropriate information for that particular client.
Okay, excellent. So would you mind walking us through a very small config snippet here describing how you might set this up in the config file?
Yep. So this is a standard class. We've also added that for V6, and we'll talk about that more later on. But in this particular case, it's just like a V4 class would be. You have the class name. You have the match to describe why this particular client should be in this class. In this case, we're just using a simple subscriber ID as an example. So if the subscriber ID were to equal third floor, it would be part of this class. The big difference is simply the V6 relay part, and this says look for this particular option within the V6 relay rather than just in the client. If you were to do a match if DHCP6.subscriber ID, we just look for it in the client space. By using the V6 relay, you say look for it in the relay space. The one specifies which of the clients you want to look at. As I mentioned earlier, there's up to 32 clients. One is the one that is closest to the, or 32 relays. One is the relay that is closest to the client. 32 is, if you had 32 of them, would be the one closest to the server. 0 is the degenerate case and says use the client space. If you have put in a number that's greater than 32, then we will find the option, the relay that is closest to the server, no matter which number it happens to be.
Okay, and we would like to say here, if any of you end up using 32 relays, please do let us know. We think that'd be an interesting case. And with that, I think our poll is finished, but I'm not seeing the poll results at the moment. Maybe they'll pop up here in a second. With that, we're going to move. Oh, there they go. So we have roughly 32% of you are using relay options in IPv4, and about 36% are planning to use them with IPv6. So good. We hope that you find the option useful in 4.3. So now we'll move on to on-expiry, on-renew, and actually on-commit features as well. So this has been used in DHCP v4 for a while, and essentially what we find most often is that people are doing things at these particular events. Usually it is logging something. And so, Sean, if you would, walk us through what we would be able to do now based on this configuration snippet here.
Again, this is the on-commit, on-expiry, and on-release are the same as they are for v4. We've just expanded them to be able to be used with the v6. So this should look pretty similar to anybody who's already using these. This particular snippet is from one of my test files, so that's why it's got all the on test and so on. And it is just an example more than anything else. You'd probably want to do different things for your own purposes, but it shows what you can do. So you have the on commit, and then log, so we're going to log the information. Info is saying that we're going to log it to syslog, the info level. Then concat is building the string that we're going to log. On test client 5 commit is just the prefix so that I know which one I was supposedly doing. And then option DHCP6.client ID is actually printing out the client ID so I can compare it to the client 5 that I expected and make sure that I did get what I expected. This particular test is testing out the inheritance features. So as with v4, the on-commit, on-expiry, and on-release can be specified in different levels in our inheritance, at the global level or at the host level or somewhere in between. And this test was to see that the inheritance worked properly.
Okay. And I believe the next slide shows that it did.
Yep. So this is the result for it. And as you can see, I have things scattered around somewhat. So one is a client, one with a host declaration. That's what we see here for client 5. Some of the others just got subnet declarations and different subnet declarations. And I was trying to make sure that all of the ones ended up where I expected them, that we did the inheritance and the handing out of addresses properly.
Okay. Now, would another use of this be, some people like to see which IP address was given to which client. Could you do some tweaking around with that here to have that logged here as well?
Yes, you could log the NA or TA or PD options. You would have to do a little bit of work to just get the address, but it is the information is available.
Okay. All right. So now we're going to talk about some additional IPv6 options. One thing I hope you're noticing a pattern here is that a lot of this is based on things that people had gotten used to doing with IPv4, and so we're doing a lot of work to make sure you can. A lot of people want to keep some of their similar processes in place as they transition to IPv6, and so that's part of our work here. The other thing is that the standards have certainly come a long way since over the past several years in terms of DHCPv6 and IPv6 standardization all the way around, and so we're just trying to have our software match up what the standards are doing at this time. And so I'll ask Sean to talk about some of the DHCPv6 options that we're looking at for 4.3.
So these are just some of the options. We actually have a slightly larger list than this. And basically, we're just going through and putting in pound defines for them. For any of these that have specific protocol meetings, we haven't gone off and started using them, but this will make it a lot easier for you to access them if you so desire. Previously, you could define them yourself and use them. Our configuration does allow that, but with this, it'll be more common and it'll be predefined, so you don't have to go do that particular work. The one thing with that is if you've already predefined some of these, we have included pound define in our site.h file, basically one for each of the RFCs, so that you can select which of these you might want to include or disinclude. By default, they're all included, but this will, if you have a particular one, say you've defined relay ID and you like the way you've defined it and you didn't like the way we defined it, you can continue using yours rather than being forced to switch.
Okay, and that actually brings us right to our poll question. We would like to find out, have any of you used any of the DHCPv6 option IDs between numbers 40 through 80 already for any user-defined options? And while you're working on that, we'll move to the next topic, which is class support for IPv6. And so here we have just the standard DHCP option inheritance hierarchy. Obviously, the one there in purple, client class, is what we're adding now for v6 and 4.3. And Sean, would you walk us through a little bit about the hierarchy and what you're adding here for IPv6?
Yeah, so the hierarchy is currently pretty much the same for both v4 and v6, with the exception of the client class. So if you define something at the global level, that affects everything, but you can override it by defining something at the subnet or the client level. What we've added here is the client class for v6, and again, it's done pretty much the same way as it was done for v4. So if you're already using them for v4, and you want them for v6, hopefully it'll be a pretty simple transition, but it's just adding that one extra inheritance step.
Okay. And with that, I think it'd be useful to look at a scenario, and so I think this one is based on sort of a campus idea where you have certain staff and students and guests. And so if you would, what's going on, let us know what's going on here in the configuration file to make use of these new classes.
All right, so again, this should look pretty similar to anybody who's using class information. And again, this is an example one from one of my test beds. We have the log information there just to show what's going on, so that when I run my test, I can see that things happen appropriately. The client ID is probably not what you'd really use in this particular case if you were just having a class, but it makes a good example and a good test bed for me. In a more normal case, you'd probably use a subclass for client IDs or match on something else if you were just going to have classes without subclasses. But it shows the effects. all of this is pretty much the same, that you're simply doing this for V6 instead of V4, that you match on the option and you specify the option, the value of the option. And the logging, like I said, is just showing us what's going on. And we can have our 3 different classes. If we go to the next slide, please. We can show the classes being associated with pools. In this particular case, an additional thing is the pool 6 statement. This allows us to group the various items with an allow or deny statement to, again, give us the class, the use of the class. In this case, we have each class maps to 1 pool. The staff class gets a better pool that you get both TAs and NAs as well as prefixes. The students and the guests don't get prefixes or TA addresses. So you can see that you can do the different thing. Again, it's a pretty simple example, but it shows some of the opportunities you have. More likely you'd have the students might get access to, say, a different printer versus the staff, and the guests might not get anything. You might give them just a captive portal type address where they can log in and connect up to a web browser or a web server, and then put in their information and actually get turn into a staff or a student, so you could give them the appropriate access.
Okay, cool. Thank you, Sean. So that concludes our part of the webinar dealing with the V6 features that we think you will find most useful. We're going to switch now to talk about some DDNS changes that are occurring. This also does obviously affect IPv6 in some ways as well. Essentially, when you're wanting a V4 and V6 client to share the same name and you want to do that via dynamic DNS, you're going to have to switch to the new standardized DDNS Update Style. And as I mentioned earlier, you know, the standards have come a long way over the past several years. And so here at ISC, we implemented a DDNS Update Style interim, and this was before the standards were finalized. And now that there is some finalization there, we are moving to what is defined there in the standards. And so, Sean, if you would, talk a bit about the differences between the interim style and the standard style.
Yeah, so in sort of 50,000 foot level, they're the same. They do the same basic thing, which is generate a tag to put in DNS so that you can tell if this is the same client from different servers or a server and a client or whatever. At the detail level, they're different. The interim one used MD5 for doing its hashing, and we used a TXT record. In the standard, they ended up using an SHA record or SHA hash and using a DHCID RR record. So at one level, they're doing the same basic functions, but the exact details changed between the two of them. So if you were to go look into the DNS, you'd see, instead of the text record, a DHCID RR record. For most purposes, most people won't ever have to go look at this, that it'll just be in the DNS, and you don't have to go really care about the details. We've tried to make sure that it will affect you as little as possible.
Okay. And so when one upgrades to 4.3, how do they go about changing this update style?
Okay, so in order to turn on DDNS, we have this DDNS update style statement in the configuration file. The very oldest of these was something called ad hoc. That was an old one done via scripting languages, and it's kind of awkward. As part of 4.2, we deprecated it, but we left the code in place. In 4.3, we've actually yanked all the code out, so that one is completely gone now. Most people should be using the interim style, so all you'll have to do is change from interim to standard to use the new one. This is done per system, not per zone, so you have to decide that anything served by that DHCP server is switching over. For the most part, if you're running a single server, that's really not an issue. If you're running multiple servers, you do want to make sure that they are all doing the same thing so that your DNS stays consistent.
Okay. So those of us that have been administering these types of systems will know that anytime you make certain changes like this in a config file, often there is a transition that needs to occur. So this is no different from that. So Sean, could you talk about what the transition options are and what people should consider when they choose one of these? And also, I found this a little humorous when I first read the slide, that we have a slow transition, which is faster than basic. So could you talk about a little bit about the speed there and the terminology you're using?
So the transition itself is simply to switch that text to a DHCIDRR record and change the format of it slightly. We will take care of that. That the basic transition is to handle updating records automatically. So if you have a client and it has logged in, gotten a DNS record, and then gone away and come back sometime later, when it comes back, we will attempt to replace the record. There's something called update optimization that we use to decide how often we should do this. If the record has expired or if the name or the address has changed, we will replace the record. If update optimization is turned off, we'll replace it whenever the client renews. So in that particular case, we will automatically update the record, the DNS record, from a TXT to a DHCIDRR. So that's the basic, and that just will always happen. We will look in the lease file and remove whatever we think is in the DNS and try and add whatever the new thing is. Now, the slow transition and the way it's faster than basic is if you are doing what a lot of systems do and you come into work on Monday and you get a lease for a week, and every Monday you come back and you're renewing your lease, you will never change your IP address and client map or client name mapping. So you'll never really update the DNS again. In the slow transition, we say that if a transition from interim to standard or standard to interim is also something we should update on. So at that point, if we see that you've changed from a text to a DHCIDRR, we will send along the DNS update. And so slowly, over time, all of your clients will get updated, and you won't have to do much of anything. By default, this is turned on. There is a compile time option to disable it if you really don't want it. Mostly that's so that it can be turned off after the transition has happened. So you've done this a month later, everything's been updated, you can go turn this off. It'll save a very small amount of resources on the DHCP server. Eventually, we'll probably remove this code when people have had a time to transition all the way over to the standard.
Okay, that makes sense. Thank you. Okay, now we're going to move and talk a little bit about how we've extended the OMAPI functionality with subclass control. So one thing that we hear very often when we ask people what they would like to see done in DHCP, we hear very often, I really want to be able to make configuration changes without having to restart the server. And so the current mechanism of doing that is via OMAPI. And so we hear you, and because we hear you, we've added some more functionality to OMAPI, and in this case, it's subclass control. So note that you already have to have a class defined with an associated address pool. And once that is done, you will then be able to add clients as subclasses to that class remotely via OMAPI commands. And actually, Sean is going to take us through what the configuration will look like and then actually show us via OM shell how to do the modifications via OMAPI. Sean?
So this is a pretty typical configuration file. It has two classes, and each class has one subclass. With our sort of examples of professors and students, we're continuing that. So we're matching on the hardware address, so the subclass has a 1 for the type and then the ether address. So we can see that, again, this is part of my testing stuff, so the lease limits are in there just to give me a differentiator between all the different classes and subclasses. so that when I look at things, I can see that, yes, I got the right one. Next slide, please.
Okay.
So here's the pools that would be associated with that particular, those two classes. They're fairly simple pools. In reality, you'd probably have more stuff there. But again, for testing purposes, this gives us a chance to see that they get the right, the clients get the right addresses and so on. And we have one pool for each of the two classes.
Okay.
So this is where we're actually going to create a subclass. The stuff in blue is what you're typing. The stuff in black is what the OM shell program is returning to you. The first three are simply connecting up to it. Those of you who use OM shell probably kind of understand that it's a little bit weird, but it does some odd things. So the first thing you do is you connect up, then you create a new subclass on the local OM shell side. Then you start filling things in. In particular, you set the name, which means you're choosing the class that you want this to be in. For this example, we're choosing the professor class. Then you set the hash string, and this is saying that this is the subclass that I want it to be. So this has all made the object on the OM shell side. When we do the create, that pushes the information across to the DHCP server side, and we get back the response that it's been created. And you can see that the lease limit is 4, which means it's inherited that 4 from the class that it was actually being created off of. And then we do the close just to be tidy. The result here that you're seeing now is the information that would get put into the lease file. As this is a dynamic subclass, we need a place to put it, and that place is the lease file. So we simply tuck one of these in to show that here is what happened, and as you can see, it's got the appropriate information, the subclass, the class name, and the address type.
Okay. And so this was on creating subclasses, and I believe you can also remove a subclass via OMAPI, correct?
Yes. And we skipped the connecting because we're already there. So we, again, create a subclass and fill in the appropriate information. This has to match whatever we put in before, so professors and the hash string. And then when we do the open, that does the connection back to the DHCP server. Again, we got the information from the server, and then we do a remove, and it removes it from the server. We then proceed to put a deleted tag into the lease file. This is just another statement, so you'd see both the previous one and this one if you looked at the lease file, until such time as we rewrite the lease file, at which point they'll end up getting removed, because this information won't be in the configuration when we rewrite the configuration.
Okay, excellent. Thank you, Sean. I think it's really good to see additional OMAPI functionality being added. I know a lot of people will find that very useful based on what I hear when I talk to folks. So that really concludes the part about, for this webinar, about the major new features that we think will be most beneficial to you in 4.3. So now we'll spend a little time. We wanted to make note of 2 items that are being added that were brought to us as submitted code. So this first one actually was submitted on DHCP-Users quite a while back. But there was interest in it, and a lot of people found it very useful. Our friends over at Allianz actually have let us know that they're making use of it in some ways, and so they have requested that we include it in the code so that they don't have to keep repatching their systems as they upgrade. And so I'd like to ask Sean to talk about that particular patch and how it might be of use.
In this case, the DHCP inform processing takes a different path through the code than the main processing. DHCP inform is simply the case where a client is trying to get information. It already has an address, and it either has a static address and wants to get other stuff, or has gotten an address some other way, but wants to get more information. So previously, we didn't do this subnet selection and the host declarations. So if you had a host declaration for this particular client, we wouldn't notice that, and we would simply give you other information. This says, look at the subnet. If there's a subnet option, look at that. If it exists, try and find the appropriate subnet. If there's a host declaration, try and find that and use that to do that inheritance that we saw earlier to choose the most specific matching information. So this gives you potentially a little bit better control over the information you will hand out to a client if you're doing DHCP informs.
Okay. Thank you, Sean. And so the other thing that we've included that was submitted is a utility called DHCP lease list. It's actually a Perl script, and it was posted on a site a good while ago, but a lot of people have asked for this as well. What it does is it produces a formatted list with columns with things like MAC address, IP address, valid until, et cetera, from your leases file. And on the next slide here is a little sample output of what this utility will do. So this is another one that we've been, another thing that's been asked about a lot, and so we're very happy that we're able to include it. Note that this one will be in the contrib directory in 4.3. So, but part of the reason we wanted to show these two is that we do listen to what folks are asking us to do with the code and what they think might be useful. We're certainly not able to accommodate all requests, but we've been working to improve our process by which we accept both patches and contributed code and how we do that evaluation. So please do keep telling us what you want, and if you have any, particularly the contributed utilities, things that we can put in contrive are a lot easier to do than, of course, putting something in the mainline code. So if you have anything that you think may be useful to others, please do send it our way. And so we have a list here of other new features that will be in 4.3. We're not going to talk about those today. They're here for your reference. When we get to the question and answer section, if you have some questions on these, we'll be happy to entertain them. But they're basically here just to let you know what's occurring in 4.3 other than what we've spoken about. And we do encourage you, when 4.3 alpha comes out, to check out the release notes if you're interested in these items. So in summary, 4.3 is the IPv6 Uplift. There are other miscellaneous fixes and other features that we just listed there. There's also DDNS changes, as we talked about, and some extension of the OMAPI functionality. As far as scheduling goes, we intend for 4.3 alpha to be released this month. Depending on how our testing goes, that will hopefully occur prior to the holidays, but be on the lookout for announcements about that. And then we intend for 4.3 beta to be released in January of 2014, so next month. And we intend for the final initial release of 4.3 to be released in February of 2014. So note here that this webinar is specifically about 4.3, but 4.1 and 4.2 will be having their regular upgrades as well. So 4.1-ESV.R9 will be released roughly on the same schedule that we're doing for 4.3, as well as 4.2.6. So be on the lookout for those as well. So I mentioned earlier that Sean is very busy trying to get this release ready, among other things. So this is sort of our little payment for Sean, or our little show of appreciation, I should say. So Sean would like to know, do you use site.h to enable or disable these particular features that we have here? And Sean, would you like to let everyone know why this is of interest to you?
Yes, so this set of features are defined in both site.h and our configuration utility, and I am attempting to clean that up and sort of make it nice and reasonable. So our basic plan is to delete them from the site.h, and you'll only be able to affect them via the configure. I believe that's probably what most people are already doing. And for the files, for example, v6, you can only do them via the configure. You can't affect them via site.h. So we like to make sure that this isn't going to cause undue problems for people. It's our intention to remove them from configure or from site.h, but if enough people say that's really a problem, we'll reconsider that. So this is your opportunity to say, we have a real problem, and if you really do have a problem, when one sends his email, that might be interesting to know why it would be such a big deal. I think it's much easier to change them via configure, so I think that's probably what most people are doing currently.
Okay, cool. So yeah, please do fill out the poll. And at this time, we'll go ahead and start entertaining your questions. And a few have already arrived, so we'll just jump right into those. First question is, can we ask ISC DHCP to send forward and reverse DDNS updates of leases to different servers?
If they mean the forward to one server and the reverse to another server, yeah, if you set up, all you have to do is set up the zone statements, and you can put whatever servers you want in there for any given zone. So if you are serving 3 different zones, example.com, foo.com, bar.com, and the reverse for some of those, you could set up whatever zone statements you want, and we will honor those.
Okay. And a very similar question, and we may need to ask for clarification on this one, but can we ask ISC DHCP to send forward and reverse DDNS updates of leases with different names?
Yeah, I'm not sure what they're trying to ask in this particular question. If they're asking for per client, we will either take the client's name as it sends it to us, or construct one if that's what they're asking, what the configuration has us do, and send it off. If it has 2 different names for the same IP address, we will try and get rid of. If a client sends in the same name and it's for 2 different leases, you'll end up getting only one of them, because there's only space essentially for one. If a client wants to have a v6 and a v4 address, that's what a lot of the update is for, is to allow that possibility. So I'm not sure if I answered that question. If they want to try and explain some more, we can try and get back to that question later on.
Yeah, okay. Yeah, good idea. Next one from John Mann here. Does ISC DHCPv6 support failover pairs like ISC DHCPv4, or is there a different think we should be using?
The v4 failover, while it never did get to an RFC standard, did go through a lot of the RFC process. It was up to draft 13 before it was finally abandoned. So there was a body of work for us to work from. There currently isn't that for v6. There is work. One of our coworkers has actually been very heavily involved in the IETF process to standardize a v6 failover. If and when the failover protocol appears, we will be happy to try and implement it. I don't know when it will appear, so I can't say if that will actually happen. The IETF, I think the best description is the wheels of the IETF do grind kind of slowly, and they do grind very fine. The other thing to think about with failover in v6 is whether or not it's something you truly need. One of the big reasons you needed failover in v4 was the limited address space, that you couldn't just split your address space amongst non-overlapping pools. In v6, you do have that possibility. With a much bigger address space, you might simply be able to say, I will have 3 servers. Each server will serve a chunk of the address space that doesn't overlap with the others. The one problem with that is your clients will have to change addresses if they get an address from a different server, if the other server is down. In most cases, that's probably not a big thing. In some cases where you want to have very long-lived connections, it could be a problem. But there are different ways to think about it in v6, and especially you shouldn't just say, I have failover, therefore I'm going to do failover for v6. you might want to evaluate, do you have the right thoughts? Do you want to use the address space differently? Is there some other way you can deal with some of these issues?
Okay. Another question here is it possible to set reserve flag for IAPDs in DHCP.leases?
I'm not sure offhand. I'd have to go look that one up.
Okay. It's always good to stump the host. Very good. Let's see here. Let me check out one of these other questions. Give me 1 second. Will the ignore DUID in favor of Mac feature be available at all in V6?
I haven't decided yet.
Excellent answer. Excellent answer. And are there any restrictions to what OMShell is able to do? Any cases where editing config is always required with regard to classes?
OMShell does actually allow you to add and remove classes and so on, but that really doesn't help because we don't have a way of connecting the class to the pool via OMShell. So that's why we strongly suggest in that example that you pre-build the class in the pool and you set all that up, which is probably what you really want to do anyway, that you want to be able to say, this is what my topology is, this is how I've set up the classes and so on, and then, oh, I want to add new clients to that via subclassing, but you probably really don't want to be adding a class on the fly. That's probably something you want to think about, redo the configuration, execute it during some sort of PM type period. So OMShell does allow you to do some stuff, but it is certainly doesn't cover all possible options.
Okay, excellent. Here's another one. I'm still trying to grasp the concept of DUIDs. Will version 4.3 or planned versions make DUID handling easier?
So we've tried to make it a little bit easier. DUIDs are the next step for client IDs, for those who haven't looked at them yet. And they are somewhat longer, and they have one particular complicating feature. The most standard one is something called LLT, link local address and time. So instead of just using the MAC address as we might have done in client IDs, we take the MAC address and prepend it with a timestamp, a 4-byte timestamp. This makes sure that the resulting DUID is indeed unique, or most likely unique. In our particular client or server, we generate this once at the start, put it into the lease file, and then reuse it from the lease file whenever we do a restart. Other clients or servers may react differently. The problem with this is it becomes difficult to pre-allocate things. In the sort of standard case now, a lot of times you'll have the MAC address printed on the outside of the box. You can bar scan it, and your IT doesn't even have to open the box to say this new laptop should get something. With an LLT, you really can't do that. So what we have done, and we actually did this in 4.2, is expand the Ethernet construct in host ID so that it will try and strip off the front pieces and just get back to the MAC address. This is not guaranteed. The DUID may be constructed in different ways, so you may not have a MAC address there. But it is one thing to try and make it a little bit easier. We might try and do some other stuff in the future as people tell us kind of what they need, but we haven't really made more decisions on that.
Okay, thanks, Sean. And one final question here. Can you give more information about the V6 log enhancement? Can we log, for example, vendor-specific information, option 17?
So, yeah, the logging is the on-expire, on-commit, and so on are just like on the V4 ones. any option that you can access, you can put in there. So if you can access option 17, if it's in the packet, you can log it out.
Okay, excellent. Well, thank you all for your questions, and certainly thank you, Sean, as well, for your thoughtful answers there. As I've mentioned several times, we do want to hear from you. If you happen to be at the next IETF in London, we will be demoing our next generation DHCP server there, and this is separate code from what we've been talking about here today, and some of you may know it by its code name of Kia. We actually demoed it last month at the Vancouver IETF for the first time. We're very excited about what's happening in that area and what we're hearing back in response to what we're showing folks. So please be on the lookout for that. Also be on the lookout, we will be sending follow-up email with links to this webinar recording and to the presentation. Please do pass these along if you like. And for those of you that were with us last month, we do have a new user profile survey, and this one's much smaller than the one from last month. So it is a new one, so if you would, we'd like for you to visit that SurveyMonkey link and fill out the survey for us. It's only 9 questions. So again, we use your feedback to make decisions based on what we're going to do with our software and how we're going to support it. So it's very valuable feedback. So thank you for taking that time. And with that, this will conclude today's webinar. We really appreciate your attendance and your time, and we hope to see you on a webinar in the future. That's another thing that we like to hear from you is what sorts of topics you'd like to hear about in these webinars. And so once again, thank you for your time.